stop talking about quantum weirdness. Philosophical Shorts 1. Short Philosophical Pieces. The science journalist and writer Michael Brooks gives the game away when he says that quantum theory allows for quantum particles to exist in more than one state at any one time. Brooks doesn't say that quantum particles do exist in more than one state at any one time. He says that quantum theory allows for such a thing. It will therefore turn out that this is nearly all down to measurements, probabilities, what-ifs, predictions, interpretations, etc., and not about what actually is. In other words, this is nothing like a cat or even a sand particle existing in more than one state at any one time. And everything just said equally also applies to Brooks's other words about an electron spinning clockwise and anticlockwise at the same, and a photon being both here and there at the same time. Finally, it also applies to an atom holding two different energies. So, apart from our experimental arrangements and interpretations, there's also no reason at all to be surprised that things at the quantum scale have different things said about them than things at the classical scale. Yet it's not only about size. Indeed, the physicist Sabine Hossenfelder says that it's not about size at all. Yet, clearly it's definitely partly about size. And it also depends on what it means. More clearly, the problems begin with the size, and that, in turn, changes everything else when it comes to experiments, observations, interpretations, etc. The physicist and mathematician Roger Penrose argues that different energy levels make all the difference. See here. All this particularly problematizes the issue of whether or not we can talk of particles and waves at all. It also necessarily brings in matters about the nature of experiments, measurements, mathematical probabilities, predictions, and theory generally, all of which are nothing like these things as they occur at the classical level. Again, it's not just that particles or quantum states are exceedingly small, it's that this fact alters almost everything else about the science of these particles, waves, and states. So the words we use about what happens when the exceedingly small is measured, experimented upon, predicted, etc. become the subject of probabilities, interpretations, etc. This in turn means that any weirdness is largely brought about by what physicists do. It's also brought about by how physicists or laypersons interpret matters. That is when physicists or laypersons attempt to explain and interpret quantum phenomena using classical words, classical images, analogies, with classical things, and metaphors which include classical phenomena. Finally, it's worth stating here that this isn't to claim that nothing, as it were, quantum happens at the classical or macro scale. This is something physicists, biologists, and other scientists are keen to point out. Instead, even if it does, then whatever quantum events, happenings, states, etc. do occur are still dependent on how such things are mediated by human minds or concepts, human sensory systems, human observations and experiments.